on counting outcomes. We have Patrick buying a new car. He can choose the body style, he can choose the color, and he can choose the engine type. There are 54 options when he gets ready to select, okay? 3 body styles and 2 engine choices. We got to figure out how many colors are available. So who can give me some information? We need to write an equation. What's the equation going to equal? 54. Because that's like the total option, number of options he has. Equals 54. So when we were back over here looking at your different options, what operation were we doing? If we have M ways and we have N ways, then you combine the activities by multiplying them to M ways. So we're going to be multiplying to figure it out. So, what do we know? What are we provided? Do we know anything about the body style? We have 3. Do we know anything about the engine? And we don't know color. So that anytime we don't know something, what do we use? An X. Got that variable in there. Everything being multiplied. So that means we have 6x equals 54. So what's x? So there are 9 color options for him to choose from. Does that make sense, the setup? You see what you can do with number 12. We're looking at how many drink options. So, what does the whole thing equal? 63. Any questions on the setup? Did you end up with an answer? What'd you get? 3. All right, Gabe, talk us through. How'd you get 3?
Well, there's 63 total ways, and there's 7 sandwich options, and 7 times 9 is 63, and if the snack and drink are equal, 3 times 6 equals 9.
All right, so to set that up, we know that the the drink options equals the number of snack options. We aren't given what those are, so those are our variables. But they're same, right? So times x, come on, right, little pen, there we go, times x. So that's going to be 7x squared equals 63. And so x squared equals 9. And it's like Gabe said, we know that's 9, but what do you do to make those be the same? X equals 3.
Wait, where did you get x squared equals 9?
63 divided by 7.
Oh, I see.
All right, possible outcomes. That's what our denominator is going to be, right? When we look to figure out, that's kind of like our total options of things. So I'm going to call that our PO for space and time, possible outcomes. What is the probability? We're tossing coins. When I toss a coin, how many options do I have? Two. Okay, that's our first toss. What the second time I toss, what are my options? What about that third time I toss? So what's our denominator going to be? 8. 2 times 2 is 4. 4 times 2 is 8. Everybody good on how we got 8? So then for the favorable outcome, FO, this is where we come up with our probability part for the numerator. So I toss that coin. I want it to be heads one time, right? So let's say the first time I toss, I get heads. What does that mean I have to get the next 2 times? Tails. Okay?
What is it? Possible outcomes and then
Favorable outcomes.
favorable.
So we're kind of figuring out what our numerator will be for favorable.
So like possible outcomes would be like if you have 12 horses and any one of them could move. But then when you have favorable outcomes,
We got to figure out how many are polka dotted or
so like okay, gotcha.
this. So it's the possible outcomes will be your denominator, and it's like the part over whole. Favorable outcome is always over your possible outcome.
Gotcha.
All right, so we want heads to happen one time. So the first time, and we're spinning 3 times. So if we get a tail the first time, then we could get a head in the middle, but that means we're going to have a tail at the end. What, Boyd? Absolutely. Then we could get tails, tails, head. So what is our probability of tossing a coin 3 times and having heads happen just once? 3/8. Remember our PO, our possible outcomes is the denom. And then you do your little drawing, set it all up, and we only had 3 options, so 3/8. Is that clicking? Making sense? Okie dokie. Let's look at 14. A month is chosen at random. Then a standard die is rolled. So a month is chosen at random. How many months do we have? So I'm going to write our PO. We know we have 12 options there for our months. A die is rolled. How many sides to a die? 6. So what is our PO, our possible outcome?
36, 60, 72.
12 times 6.
72.
Now, the probability of getting February. How many times could we get February? Well, just one time. Oh, hold on, let me write that. Well, good, I wrote it. It happens to work. February. Favorable outcome. All right, I'm going to do the drawing, kind of our sample space. We could do a tree, but I'm going to do a sample space for this. So if we have February, and then the probability of getting a number less than 5.
4.
We could have a 4. What else could we have?
3.
We could have a 3. We could have a 2. We could have a 1. So we could have February with 4, or a 3, or a 2, or a 1. So what is the final probability of getting February and a number less than 5?
1 over 18.
1 over 18. 4 over 72.
How did you get that?
Okay, do you understand where the 72 came from? You sure?
Yeah.
Okay, so 4 over 72. Y'all stop me now. Does the 72 make sense? Do you see why I know we're only doing, like, choosing a month one time, but do you see we have to take into account the second event and how that plays into our one event for the second one. So it could have been a 1 or a 2 or a 3 or a 4. We don't know, but we got to take that into account. So there's only one February. So it's like having your umbrella of the drawing. So 4 out of 72, which is 1/18. So do you think that's a very high possibility of that happening? Or probability? No. Not really. You do 15. How many cards in a deck?
52.
And toss of a coin. There you go. So there you've got the possible outcome nailed down. What operation do you do with that? Multiplication. Perfect. So what is the possible outcome? What's our denom? 104.
So would you use like?
Okay, let's draw it out. How many aces are, okay, what is the probability of getting an ace?
So we use like 4 aces, or
We're going to have an ace of hearts, an ace of diamonds, an ace of clubs, and an ace of spades. Okay, we could get one of those. But then what is our other option when we toss the coin?
Heads or tails?
And we want it to be tails. So a tail, whoops, come on. Tail. How many options did we have? 4.
That's right.
So do you see how we got the 4 though? So what would be our simplified probability of having an ace and tails? 1/26. Perfect.
Can you tell me how you got 4?
Sure. How many aces are there? 4. So I wrote those out. Ace of hearts, ace of diamonds, ace of spades, ace of clubs. That's what those look like words over there. But then when we toss the coin, we only want tails. So T. Once. So then you count how many drawings we came up with. 4.
So on the
1, 2.
on 72 or on the 14, when you got 72, so did you just do?
We had February,
Uh-huh.
but then we were looking for numbers less than 5. 1, 2, 3, 4.
Uh-huh.
So we had to write, I guess we could have gone at it a different way, but it said February 1st. We could have said 1, 2, 3, 4, and then it would have been our February.
So how did you get to 72?
Well, there are 12 months,
Uh-huh.
and there are 6
Oh, that's the
die.
denominator.
That's the denom. You start with that to figure out what all are we working with, and then pull from that what we need.
Yes, okay, I figured it out.
All right. A standard die is rolled 2 times.
636.
Yeah, very good. And we want to land on 1 both times. 1 out of 36. Very good.
That's the answer?
1 out of 36. Okay, we know it's 6 times 6. This is our possible outcome. All right, so the first time we roll it, what do we get? We only want a 1. So that would be 1 out of 36.
But there's 2 of us.
The second time we roll it, what's our option?
1 out of 36.
Well, I should have done 1 out of 6. Sorry, my bad. Hold on. No, my bad. Let me erase just a sec. Oops. So when you do it the first time, we would have 1 out of 6.
How do you know whether to common denominator, like use 36 of the common denominator or 6 of the common?
It's gonna, when you're through with the whole thing, it'll be 36. And so this one, because it was one option that you're gonna have as your answer, we can go ahead. You didn't have we wouldn't have done a tree for this because it's just one thing happening. So we didn't have 4 different things here and 2 different things coming together and we were having to draw and count it all up. This was back to being very simple. Roll a die, one thing happens, 1 out of 6. Oh, the next one is roll a die, one thing happens, 1 out of 6. And then multiply together. Very unlikely that it would happen. All right. And the other way, I guess you could have done it, favorable outcome, we've had a 1 and a 1, which would just be our 1. Look at each spinner to the left is spun once. What's the possible outcome? 40. 5 on one and 8 on the other. So possible outcomes, 5 times 8 gives us 40. What, did I lose you on that one? Well, on the first spin, there's 5 colors. On the second one, there are 8 numbers. So the probability of getting yellow when you spin, but I mean, how many yellows are there? 1. So what we're going to do then, we're just going to write down a Y. That would be our answer. But we got to get an even number. How many even numbers are there? 2, 4, 6, 8. All right, so that means we could have a Y with 2, a Y with 4, a Y with 6, a Y with 8. So what? 4. 4 options. So 4 over what, Gabe? Yes, sir. What'd you do?
I just did 1/5 times 1/2, or yeah.
Yeah, that works too.
Okay.
You do the first event and do the second event. I'm glad you're seeing that because what we're moving into is that. All right, that's exactly it. I was hoping y'all would come to see there's a way to do it other than writing out. So love that. 18. You still have that same spinning doodah and it is 40. What's our answer?
1/10.
1/10 again. Okay, go to the next.
Wait, can you?
Do y'all see that's 40?
I see it's 40.
All right. We need orange or blue. What do we have for orange or blue? We're going to do it Boyd's way because this is going to walk us into Boyd's way is going to work. So Boyd, our first event. What is the denom for the first event?
2 bids.
We know 5. So, and orange or blue is 2. Do y'all see how he came up with 2/5?
Yeah.
All right. Our next spin, what are our options at the bottom? 8.
1/4.
And we need it to be a multiple of 3. That's going to be a 3, a 6. We had 2 options. 2. So it's 1/4. And you multiply. And you get, or you could even simplify, go ahead and cancel out.
I didn't do that.
But you did in the end.
Yeah, I did that, yeah.
Yeah, you told me 1/10. All right. This is leading us into compound probability.
This is not already compound probability.
It is. We just didn't call it that yet. And now we're calling it. Here we are. Compound probability. The sheet that I just gave you at the beginning of class. But there's a little caveat to it. To me, this is fun.
Which sharpener is the best for?
Thank you, Esther.
I think that one's okay. Huh, freezing.
Hey, Royal.
I don't know about turning it off, but I'll do my best. I'm freezing. All right, we'll see if that gets any better. All right. Everybody have their sheet out? Ready to roll. The part of this is really, I think this is going to make sense. And I think that this is like a fly-through thing. There's just one little caveat we got to keep up with. Here we go. So, a compound event is what you've just been working on. It's the probability of two or more simple events coming together. So the probability of two or more simple events now, if I say something is independent, what's the difference between independent and dependent?
Independent doesn't mean anything else, you just kind of has to rely on.
Ah, so if you were talking about something being independent versus dependent, which one would be affected by the other? Independent or dependent? Dependent. So keep that in mind. We're going to be looking at independent, where it's just like what you've just been doing. Dependent is going to take a turn. So you've already kind of got this figured out. We know we're going to take the two events, figure out what they would look like, and then we're going to multiply the probability of the first by the probability of the second and simplify our fraction, which is what we just did on the counting outcomes. So how many standard die sides are there?
6.
And here we have over here, and then getting an even number. Okay, so we're going to roll that die twice. So what's the denom going to be both times? 6. Come on. There. And what's the probability of getting an even number? 3. What's the probability of getting a 5? 1. And then we multiply. And we get 3 over 36. But y'all, I would highly, highly, highly encourage you to see if you can cancel out before you do the work. Just makes multiplying a lot easier. So the 6 and 3 can cancel out, or you could cancel out the 3, 6. So we would have a 1 and a 2. So we would end up with 1/12. You do number 2. The probability of 2 or more simple events occurring, which is what we've just been doing.
Yes.
And then we multiply to figure out the 2 separate events and multiply.
Oh, okay. I got you.
All right, so we toss a coin 3 times. What's the denom? And then what's the numerator? And we have that over and over and over. So what is our final answer? 1/8. 1/2. Where we got 4? 1/2. 1/2. 1/8.
Would you not ask me?
So we have a spinner to the left. We have 2. They are spun once. So what is our denom for the first spinner? 12. What is the probability we will land on 11? 1/12. What about the second spinner? What is our...
2/5.
Where'd you come up with 2?
Because there's 2 reds.
There's 2 reds. So we have 2 options. Read your words. We have a red and a red. So 2 1/5. And we could simplify that bad boy, and we end up with 1/30. Unshaded than green, you do it. What'd you get?
No, I'm not there.
Oh, okay.
415.
Bro, I got 215. It's 215.
There's 2 green.
There's 2 greens.
Why is there 2
I know.
greens?
Because there's only 1 blue.
But if you divide them both by 4, 15 by 4 is 15, 8 by 4 is 2.
What? Okay, what is the first one?
It's 4, 12.
Ah, unshaded.
Oh, unshaded.
Yeah, that's a mess.
When is there 2 greens? Like,
I know.
there's not.
We haven't had any repeats, and now they're throwing things at us. All right, so we have 8/12 times 2/5. And if you didn't simplify, that's 16 over 60. But then you should simplify and get 4/15. Ooh, at least 3. Then blue. Hey, Lillian, there are no blue repeats. For which one?
Wait, hold on.
Not like that, bro.
So, at least 3. Does that mean
Bro, what?
more than this?
Can it be 3? 3's your baby. It didn't say at most 3. It's at least 3. What?
So would the denominator...
For C? No.
Would the denominator...
Are we talking C?
What is at least 3 mean?
When we spin, you get 3, but it could be 4, 5, 6, 7, 8, 9, 10.
And can it be 3 also?
At least 3.
Is the denominator 11?
For the first one, there's 12. For the final answer,
For C. Just like...
at least 3. There's 12 options. Yes. There's 10/12. And there's only 1 blue, so 1/5. Except my 12 didn't write. There we go. So 1/6. Even and shaded. Okay, remember, if it is shaded and it's even, you can't count it.
It's 1/3.
It's a game.
What'd you put?
How many are even and shaded? 2.
Yeah.
2/12, and then that are not red, 3/5.
All of them are even and not.
So is it like you count 1 and 2
Even and
as the
shaded.
denominator? Like
Isn't that
12 in all.
Isn't that-
12 for the first one, 5 for the second one.
So like you take 12 in all, and there's 10 at least above
Even
or at
and shaded is
3.
10 12.
And then there's 1 blue out of 5.
Mm-hmm.
Multiply that to 1/6.
Well, you simplify, you would multiply, you would get 10 out of 60,
Multiply.
10 over 60, and then 1/6.
How many days are in June?
30. All right,
Wait, how do you get 2? Is it
oh,
10?
so even, let's look over here, back over here and look at even. Even and shaded.
Yeah.
So like, is 12 gonna work? No, because it's not shaded.
Yeah, but it's even.
It's even, it's gotta be both, even and
But
shaded.
I thought it meant like even. and
If it
shaded.
said even or shaded, we could go, but it's gotta, and remember back when we were doing less than and greater than? Less than had to be both of them coming together, that was an and. So we only have 2 and 8. All right, we're going to move to the next page.
Wait, how many days are in
30.
30.
We want to talk about dependent. What's a quadrilateral? There are 4 sides. All right, quad, 4. All right, look at number 6. Before we're going to do one thing before we do dependent. Number 6, there are 5 red, 1 orange, 2 green, 4 purple in a bag. Our marble is drawn. What does replaced mean?
Nothing
Like,
happened.
I
Oh,
take
God,
this,
take 'em back
you
into
put
it.
this.
All right, if I have a bag and I take one out,
You put something back in.
I'm putting it back in, right?
That's an equal amount.
Okay. So, what would be our denom for this?
Which one?
6A.
Wait, it's not.
How many? 5, 1, 2, 4.
12.
12. If I want to draw an orange, 112.
No, we.
All right, I want to draw purple. 4 12s. What's the final simplified doodah?
136.
1 over 36 that's going to happen. Not a very high chance. So what about D? They're both red. What's the option of having,
Wait, it is replaced?
replaced? It's put back in.
So, do you not simplify that 4 to 12?
Sure, we can, which would be 1/3. And when you multiply that, you get 1 over 36.
25 over 145.
25 over what?
144.
Yeah, 144. Close, yeah, horseshoes. Red, we have 5 red marbles. And again, we have 5 red marbles. So we have 25. And we do not bring radicals to the party. So we don't simplify that. Now, dependent, ma'am.
Okay, so if you like didn't replace it, would it be like
Okay, Elise, this is perfect. Here we go. We are now not replacing.
okay?
So we're going to, this is where we get into dependent. In other words, if I pass something out, maybe we have a Snicker bar or a set of cookies and we're sharing food. And oh goodness, we had 12 brownies and we shared those 6 of them and 1 got eaten. We don't have the same amount of brownies anymore to continue sharing, which would be the case. If we had Snicker bars, I would eat one. I can't help it. So that would affect the probability of something happening. In this case, we're going to be taking a marble out. And remember, when we drew a probability, that is the favorable outcome. So if it says the probability of a red coming out, we're saying that that one that comes out is red. All right? But then we don't put it back in. So what does that change? The numerator or the denominator at this point? The denominator. We have less in our bag now. So how many are in the bag to begin with? For 7A, 25. We work it the same way at this point. How many red? 4. All right, but we only pulled out 1, and we set it over there. So how many do we have in the bag now?
3.
24. But red, yes, we would then have just 3. You're right. But 24. And that's going to come in handy in just a second. But now we're going to draw a blue. How many blues do we have? What are our options? 12. 12, no. Because what we drew was a red.
Oh.
See what I'm saying? If we didn't draw blue, we drew a red, and when we say we're drawing that, we're saying that the favorable outcome is that we actually did draw the red. So it doesn't affect how many blues are in there, but it affects the total number. So what is our answer for this? Simplify all around.
What's 450 go to?
12 over
Yep.
150?
No, we're gonna have 12 over 24, which is 1/2. So 4 times 1 is 4. Oh, we can simplify again. 2/25. All right, look at D. How many do we have all together?
25.
25. We've drawn a yellow. What's our option for drawing a yellow? Yellow. We have 6. But now we're saying that we did draw a yellow
Do 2 yellows.
and we took it out. We only drew 1 and we set it over there. So now how many are in the bag? 24. We took it, we didn't put it back in the bag.
And then there's 5.
But we took out a yellow the first time out. So there's only 5 in there that are possible yellow. So it matters what you draw first as far as color goes. So what's our final answer? 1/20.
It's clicking.
Is this clicking? Making sense? Keep up with what the first one looks like and how it affects the
Are
second.
the ones we skipped over, are those homework?
No. All right, number 8. We have 16 lottery balls, but they are numbered 1 through 16. Okay, so what's our denom? It's going to start off as 16. What are the options for them being even?
8.
What are the options of them being, okay, and we put 1, we did not put it back. It's not replaced. So then when we go to draw again,
15.
we have 15. But then how many odd do we have? 8. Because when we drew an even, that doesn't affect our odd. So what's our final answer?
8 over 30.
Simplify.
Into 4 over
4 over,
5.
no. 4 over 15. You do D. No, do B. Yeah, B. This matters. How many 10s do we have?
1.
So we have 1 over 16.
And there's 0.
We don't have a 0. But now we take it and don't put it back in. So what's our denom?
15.
15. What kind of number is 10? Is it even or odd?
It's an even.
Even. So it affects even the even numbers. So what, to get an even, 7. So what's our final answer? Yep.
You can't simplify that.
Nope.
Well, we have will we have 16 times 50?
Oh. I'll take that into consideration. All right. Does this make sense? It's a little more. You've got to keep up with what happened the first time around. It would never hurt to go up in the word part and list out the numbers 1 through 16. Then visually, y'all use your visuals. And if you pulled out 10, then cross it out. All right? And then see how many, you had left or whatever, depending on the way the question's set up. All right. Get your homework.